In this video, I will be going over another problem involving the average atomic mass of an element. Let's go ahead and read the problem. Neon is an inert gas with 3 naturally occurring isotopes. According to the periodic table, the average atomic mass of neon is 20.18 grams. If neon 20 has a mass of 19.99 and neon 21 has a mass of 20.99 with a 90.48% abundance and 0.27% abundance respectively, what is the mass of the third isotope? So the first thing you want to do when you're reading these problems is pretty much you want to kind of separate everything that you're given and write out all the information that you're given so that you can more clearly sort of come up with a plan to approach this problem. So the first, probably most important thing here, piece of information that we're provided with here is the average atomic mass of neon, right? So we are given the average atomic mass, which is 20.18 grams. And we are also provided with very, very important information. They tell us that we have 3 isotopes, right? We have 3 isotopes for neon. Neon has 3 isotopes is what we are told here, because we are told that neon 20 has a mass of 19.99. This is our first isotope. And neon 21 has a mass of 20.99. This is our second isotope. And then they go ahead and ask us what the mass of the third isotope is here. So this is where they tell us that we have 3 isotopes. Now we only are given the masses of 2 neon isotopes, and those are 19.99 and 20.99. Additionally, we are also only provided with 2% abundances, and they are the percent abundances of these two neon isotopes. And these percent abundances just so happen to be 90.48% and 0.27%. Right? So we can sort of set up our problem and see what we are missing, right? Let's set up our weighted average problem as if we were going to calculate this normally. So I'm going to erase all this and write out the weighted average problem so that we can try to solve for the mass of the third isotope. So if we were going to calculate the average atomic mass of neon, we would set it up like this. If we were calculating our weighted average, we would set it up something like this. 19.99 times 0.2099 plus 20.99 times 0.0027. Now, one thing that I want to point out here, I don't want to confuse you guys. I did skip a little step here, and that is that I went ahead and I wrote the percent abundances as decimal places. So I divided these two values by 100. I divided this value and this value by 100, and then I went ahead and inserted the values into my weighted average problem. Now I did this because I don't want to generate any confusion this time around. And so since we are provided with the average atomic mass already here, it would be too much work if I inserted them, the percent abundances, as percentages. Then I would be forced to multiply pretty much the average atomic mass given by 100 and then work from there, which is just confusing. And so what I did right now is I just went ahead and I just divided these two by 100, went ahead and inserted them into the setup. Now, if I was going to continue to solve for this problem, right? I'm solving for the average atomic mass of neon. Now I need to find pretty much, I cannot continue here because I'm missing some information. We are missing the percent abundance of the third isotope along with the isotopic mass of the third isotope of neon. We need to multiply both of those and then add that product by these two products. And so we can't do that because we're missing the information. But what I really want you guys to understand here from this video is that 90.48 and 0.27 are the 2% abundances, right? Those are the 2% abundances. Now, this is the percent abundance of the first isotope, and this is the percent abundance of the second isotope. Now, since we know that neon only has 3 isotopes, the percent abundances should all add up to 100. And so the way that you approach this problem to find out the percent abundance of the missing isotope is practically just add both of these up. And if you add both of these up, you should get 90.75. And subtract that from 100. So 100 minus 90.75, and you should get 9.25%. Now 9.25% is going to be the percent abundance of the missing isotope. So now we are not as stuck as we once were, right? Because now we know more information. Now we know the percent abundance. Now, once again, I'm going to insert this into the problem as a decimal point. So I'm going to divide this by 100, which should give me 0.0925. And I'm going to insert that into my setup once again. Now we can sort of work with what we have because now we have more information. So from the information that we were given two different, let's just recap. We were given two different isotopic percent abundances. And from that information, we were able to obtain the third percent abundance because, once again, you need to remember that the percent abundances of all isotopes of a particular element are always going to add up to 100%. And so since we know that neon has 3 isotopes and we are given the percent abundances for 2 isotopes, the missing percent abundance should be the difference between those two, the addition of those 2 percent abundances and 100. And that's exactly how we calculated 0.0925 in its decimal form. And we inserted that into our weighted average setup here. Now we can sort of work with this and set up a really simple algebra problem, really. So once again, the average atomic mass here, right, is 20.18. So this entire setup here equals 20.18, and we have all the information that we need in this weighted average setup, except for one very, very important piece of information, and that is we are missing the isotopic mass of the third isotope. And that is how we are going to move forward here. We are going to solve for that third isotopic mass, which is what the problem asks us for to begin with. So Once you add up these two, So moving forward, once you calculate or actually solve for these here, you should get your answer should actually be 18 point. Sorry, I'm writing too big. I need to keep some space here. 18.1436 is the answer of this purple box here, of those two operations there. And moving forward, we are still left with this information here. Now remember, we know what the average atomic mass is because the problem gives it to us. It is 20.18 grams. Now, this becomes a very, very simple algebra problem as I just explained. All that we need to do now is essentially go ahead and subtract 18.1436 from both sides here. 18.1436. We subtract it here and you should get 2.0364. That should be your answer to that subtracting operation. We're essentially solving for x. That's all we're doing here. We are solving for x. Keep that in mind, please. We are just solving for x. That's all this is here. And remember, we still have to work with this here. We have x equals x times 0.0925 equals 2.0364. All you have to do to solve for x now is divide by, all you have to do really is divide by 0.0925. That cancels out on this side. Divide this by 0.0925 and you should get something close to 22. Sorry, you guys cannot see that. You should get something very close to 22.02 grams as your final answer. That should be the isotopic mass of our third isotope for neon. I hope you understood how to do this problem. Thank you very much. Until next time.